Hello everyone, myself Sindhuja. I am from branch ECE. I am studying in Srinivasa Ramanujan Institute of Technology. Today's my topic on Moore to mealy conversion with examples and step-by-step process. And this topic belongs to the subject Digital Circuit Design. And the subject code is that 23 ECE 303, and my roll number is 2347A04A7. Moore to mealy conversion with step-by-step process and examples. Introduction to state machine. State machines are fundamental models in computer science and engineering. They are used to design sequential logic circuits and control systems. Understanding Moore and mealy machine is crucial for effective state machine design. In beside picture we can observe the finite state machine in mealy machine and Moore machine. What is a Moore machine? A Moore machine is a type of state machine where the output depends only on the current state. The outputs are associated with states and change only when the state changes. This often results in a simpler design but can lead to slower response times to input. And what is mealy machine? A mealy machine is a state machine where the output depends on the both current state and the current input. This allows for more immediate output changes based on input changes. Mealy machines can be more efficient in terms of state usage compared to Moore machine. In theory of the computation, a mealy machine is a finite state transducer that generates an output based on its current state and input. This means that the state diagram will include both an input and output signal for each transition edge. In contrast, the output of a Moore finite state machine depends only the machine's current state. Transitions are not directly depend upon input. The use of mealy FSM leads often to reduction of the number of states. However, for each mealy machine, there is an equivalent Moore machine. Key differences between the Moore and mealy machines. The primary difference lies in the output dependency. Moore depends solely on state, while mealy depends on state and input. Moore machines typically have more states than mealy machines for the same functionality. Timing diagrams for mealy machine generally shows output that reacts faster to changes in input. Moore versus mealy machine. Moore machine outputs are function of current state. Outputs change synchronously with state changes. Mealy machine output depend on state and input. Input changes can cause immediately output changes is known as asynchronous. Conversion overview. Converting a Moore machine to a mealy machine involves analyzing the state transitions and outputs. The goal is to create a mealy machine that behaves identically to the original Moore machine. This process can lead to a reduction in the number of states needed for the design. Step 1. Identify states and outputs. Begin by listing all the states and their respective outputs for the Moore machine. Ensure to document the input conditions that cause transitions between states. A clear understanding of the current state output relationship is crucial for the next steps. In beside picture we can see the input A state output and input B state and output in tabular column. Step 2. Analyze state transitions. Examine the transitions between the states based on the inputs provided. Identify how the output can be adjusted based on the both current state and inputs. This analysis will guide the redefinition of outputs for the mealy machine. Beside picture we can see the example for Murray to mealy conversion. A mealy finite state machine is designed such that it generates a 1 each time it detects the sequence 010. Sequence may be overlapped, that is 01010 will produce two 1 outputs. This circuit can have input X and output Z. Complete the state diagram below assuming that A is initial state. You may have to add additional states and transitions to solve the problem. And the second example is that the sequence detector from part 1 is to be implemented using a Murray machine. Complete the state diagram below assuming that A is the initial state. You may have to add additional states and transitions to solve the problem. And the third step is that define outputs for mealy states. For each transition, determine the appropriate output based on the input conditions. Outputs in a mealy machine can change as soon as inputs change, enhancing responsiveness. Create a new output table that reflects these changes for the mealy conversion. Example of conversion Murray to mealy. Consider a simple Murray machine with states A, B and outputs associated with each state. If state A outputs 0 and transitions to state B on input 1, the mealy machine can produce an output of 1 during the transition. The new mealy machine will now have outputs associated with both states and input, enhancing its functionality. Verification and converted machine. Once the conversion is complete, verify that the mealy machine behaves like original Murray machine. Create a state transition diagram for the mealy transition machine and compare outputs for various input sequences. Testing is essential to ensure the logical correctness of the conversion. Applications of the conversion. Understanding the conversion process is useful in digital circuit design and software engineering. It allows for optimization of state machines, making them more efficient for specific applications. Many real world systems such as control systems and protocol design benefit from these conversions. Conclusion and summary. Murray to mealy conversion is a valuable process that in state machine design. This conversion can lead to more efficient and responsive systems. Mastery of these concepts will enhance your ability to design and implement effective state machines. Thank you.